Here, if you're not here, look at that. All right. Anything else before we get into semi-new stuff? I'm going to review this real quick. We talked about this last time. What the Laplacian does to derivatives. It's really kind of neat. How do I write? Who remembers the notation for this first guy? These are functions of t, right?
Delta y of x.
Yeah, so this becomes a function of s, but what's that symbol there? Pretty sure I showed this to you. So little f becomes big S f, so little y becomes
Big Sy.
big S y. However you want to make it, you can actually make it look like a real y if you want to. So we did this one last time. We actually did the integral of this one last time. I don't know if you remember this, and this is kind of a neat. Let me see if you guys see the pattern here. Gather f. If you were to do that to this is kind of cool what happens. Do you see how the first piece of this is this thing multiplied by s?
Oh.
And then you subtract the next derivative at 0. So what would the Laplacian of y triple prime be? Well, you take this whole thing, multiply it by s. And then you just subtract the next derivative evaluated at 0. It's kind of neat. So this is why it's so directly related to initial value problems. So you've got places to throw those values in. So I figure we try at least one problem out. Yeah. Yeah, cool. So the idea is you attack both sides of that with Laplacian. I think this last one. Everybody got this last one that wants it? It's in the book too. See this more room over there. Chaw. So you attack both sides with Laplacian. Laplacian is linear operator. So the Laplace of y prime, I know what that is. And then what's the Laplacian 6y officially going to be? Six
Big Sy.
big SY. And say again? Laplacian of e to the 14th. Anybody remember that yet? Let me tell you what you want to do. I don't know how you do this. You need to memorize those Laplace transforms. I'm not going to make a big deal out of the sinh and cosh, to be completely honest. But you got to know the other ones. And if I was you, what I normally do is I write them down over and over again. You need to also remind yourself why they are what they are. So it's very similar to doing the limit definition for derivatives and then just starting to memorize derivative rules. And then every now and then you might remember this is the limit shit. We don't see it. We just memorize it. So it's the same idea. This is based on a process. We don't always apply the process. We memorize the rules and go from there.
I want to say 1 over s minus 4.
Yes. Coolness. And what's really cool is what's the Laplacian of 1? 1 over s. And I don't know if you guys remember e to the at is a shift. So here e to the 4t shifts it. Yeah, so it's that's why I told you that already, even though that's the next section, is because this Laplacian is actually a shift of Laplacian of 1, using that shift factor, whatever you want to call it. Right? Okay, so now what do I do? Oh, I didn't tell you this. You say, what you do now is you say, what the hell's y0, Jeff? Where was it? Y of 0 is 2, so then I can put a 2 there. Add it over, is that cool? Just trying to save myself some writing. Because what am I trying to solve for?
S?
No. Y, right? The answer to D is going to be a function. We've shifted over to the S axis realm, right? So I want to solve for big ass Y, because then I can inverse Laplace it back to Y, which will be the answer to my original question. I like it. So S is just a little, it's a player, just like X is, but the answer is going to be that function. So when I try to solve for that, are you guys everybody decent?
Yeah.
So is that cool? That's minus 2. I'm going to add 2. I'm going to take a y, s out of what's left. I did that 2 up there for a reason. Because now what do I do? Of course, to get y, s by itself.
Divide.
Yeah. So divide by s plus 6. And then as I warned you, what's going to be a big part of this? Let's see here. Partial fractions, yeah. I like it. So take a minute and try to do the partial fractions for this piece. It seems like it's useful. So I don't know, if you guys fine. Don't blame if you don't give a shit. This is like s plus a, s plus b. So the answer comes out to be, on top of s plus a would be negative 1 over a minus b, and on top of s plus b would be 1 over a minus b. So it looks like it'd be a in this case. So it's negative 4, 6, so you get negative 1 over 10 and 1 over 10.
Mm-hmm.
So, I don't know. Part of what you should be curious about every now and again is there a way to generalize something that happens often? Because now if there was 7 over this, it would just, if there's 7 over this, right, it would just be 7 times what I get. So you can kind of generalize it. Anyway, if you don't give a shit, I'm okay with that. I just was doing something while I was waiting. So, what do you get? So, let's see. What did you guys get? You got Have you gotten something yet that I
Mhm.
asked you earlier? You did get some 1/10 stuff, right?
Yeah.
I forgot already what it was. It was 1/10. What did it say D was? 6. So like I think it's 1/10 1 over S plus 6. Did you get the one things matched up? B -4 minus 6. Negative 1. Oh, so it's negative 1/10 S 1 over S plus 6. Is that what it is? Oop. I don't know. I think. S minus 4 plus 6. It's fine if you get something else. I'm just messing around. Did you guys get an answer? No. Oh shit. All right. Well, let's do this the traditional way then. Enough of this weirdness. All right. So I'm trying to break this guy up. So 1 over S minus 4, S plus 6 equals, what's the form of the answer going to be? All right, then you multiply by the LCD, you get 1 equals A, S plus 6, plus B, S minus 4. And there's a few different ways to do this, but make a little matrix, a little system of equations. A plus B has to be 0 because there's no S's. And then 6A minus 4B has to be 1 because that's what the constant is. Equating coefficients. Get out of there. There you go. 6A. I think that was an A, Jeff. Right. So then if I just to get to the cut to the chase here. Multiply this by 4, you get 10A equals 1, so we get A is 1/10. So that is the thing that's in front of S minus 4. And therefore B must be negative 1/10. And that's the thing that's over S plus 6. Cool. And then you've got this plus 2 over S plus 6. You see what I can do with this? Some of you guys are like, I'll tell you what you can do that. All right, let me stop here for a second. Is everybody cool with what just happened? This cannot be foreign. We've talked about this before, came up earlier in the semester. I told you to review it. And of course, you do everything I say, so this is known now. Did I give you guys or at least tell you where to go get the partial fractions handout?
Mm-hmm.
Yeah. Okay. Print that sucker out and have it sitting next to you when you do homework. Get used to it so you're able to do it on the test, because you know I'm going to make this happen. Like these are like terms, so this would be 20 over 10 of these, so then I'll get 19 over 10 of these. I'm writing this way for a specific reason. Because what am I going to do now? My answer is going to be a function of t. Right? I'm in S now, so how do I get back?
Universal plot?
Yeah, inverse Laplace. I like it. So if you do the inverse Laplace, so this will become just y of t. 19/10. What is 1 over S plus 6? Where does it go back to? That's related to the thing we just did up here, right?
Mm-hmm.
So where's 1 over S plus 6 go back to? E to the negative 6t plus 1/10 e to the 4t. Oh, cool. We got a little bit of time. Real quick, if I did this problem straightforward, not using Laplace transform. By the way, this is a very simple DE to begin with, right?
Mm-hmm.
So it's not going to show the true full power of Laplace. But anyway, if you kind of do this just the way we did back in chapter 4, What do I look at first? This is a nice review. Yeah, the associated homogeneous. So the ox for that would look like m plus 6 equals 0. So m is -6. That is promising. Where'd it go? There it is. Because now I get yc is c1 e -6t. And then to get yp, assume it has the form
A to the 14.
ae to the 4t, or you can do annihilators if that just makes you all tingly. You want to do annihilators. And then y prime would be 4a e to the 4t. Put that in there, 4a to the 4t plus 6a to the 4t equals e to the 4t. So I end up with 10a equals 1, I get a equals 1/10. That looks familiar. So yp is 1/10 e to the 4t. That's my particular solution, right? And then to get the constant value, I've got to use the y of 0 equals 2. Right, so far I get y equals c1 e to the -6t plus 1/10 e to the 4t. Y of 0 is 2, so c1 plus 1/10 equals 2. This looks very familiar. The 2 and the 2 and the -1, right?
Mm-hmm.
Subtract 1/10, so you get the 19/10, and then you get the same answer. Okay. Very nice. Okay, all right. Right, it's nice to see that happen.
Yeah.
Yeah. Okay. You want to do another one of those, or let's see, what was the other thing I was going to do? Oh yeah, I want to get a little bit into that. We might have time to do one more of those. Yes. Okay. Let's see. Let's do. Oops. Where are you, differential equations? There you are. Oh, yeah. Oh, excuse me. Let's try. Let's take this away. Oh, yeah, that's right. I forgot to say that. Yeah, let me say that right now before I forget. Quiz, Monday. 7.1, 7.2. Did we do? Yeah, that's right. Okay, let's see. Yeah, that one. Y prime minus y equals 2. Cosine phi t.
On the quiz, we're not going to be able to use the worksheet for the Laplace transform.
That's right. So that's why I give you the weekend. You're going to do it this weekend anyway. You're in college.
12 hours for both.
Social life. Oops. College. Oh, shit.
Yep. On weekends.
I remember. Anyway, I understand the struggle. The struggle is real. So here they tell me that y of 0 is... Where'd it go? Y of 0 is 0. That looks promising. I like that. You guys try to get as far as you can. So use Laplace transforms to solve this. call thing? I can't remember now. Let's see.
I don't think we actually did this yet. Talked about it. We'll do this next.
So if you guys remember that cosine is Jeff, is an asshole.
Yes.
And so what's going to be on the top of cosine then, if it's an asshole, it's going to take, yes, it's sine with 1. You go, sine goes, yeah, S for sine. Oh, screw you, I guess. Yeah. I don't know, it works in a lot of points. So over here, what's this Laplace going to transform this into? 2S. Cool. Of course, Jeff and his 5s. Y0 is 0, that's beautiful. So you get y s times s minus 1, so then I'm just going to divide over there. And then guess what? Or don't guess. Just do it, I guess. Oh, this is going to be cool. Just to make sure everybody's doing this correctly. What are you guys doing? Are y'all just catching up? I don't know. Are you guys trying to do some of that?
Yeah.
Yes? What partial fractions? And in this case, what's the form of the answer going to have to be? A over s minus 1. No.
Oh, no, you gotta, yeah. Plus B over.
It's an irreducible quadratic. It is truly second degree. So it's not just a repeated. If it was s minus 1 squared, it would be a over s minus 1 plus b over s minus 1 squared. It's not a true quadratic. It's just a repeated factor. This is not a repeated factor. This is a true irreducible quadratic. So it's got to be a degree below that on top. It's always 1 degree below what it is. Linear, constant. Second degree, first degree. Okay. So then you get 2s equals a s squared plus 25 plus bs plus c s minus 1. If s is 1, you can do it this way, or can you set up your system of equations? Once there's more than a and b, I'm like, screw it. And actually, normally, if there's a way to get at least one value of s that makes part of it go to 0, I do that. And then I suffer through the rest of it. So if s is 1, I get 2 equals 26a, right?
Mm-hmm.
Plus 0. So I get a is
1 over 13.
1 over 13. So how do I figure out anything else? What's something that a is related to that I can write here? A/s squared, or 25a. I mean, let's see, what's another s squared term? Let's start there. So a/s squared. So a plus what's another s squared term? What's the only other s squared term that would come out of this? B/s squared. So a plus b has to be
0.
0. There's no s squared terms. So b has to be negative 113. So how do I get C?
Um, 25A.
25A minus C has to equal, it's like 5. That's awesome. What's the constant term on this side?
2.
No?
Zero.
0. That's the S term. So C has to equal 25A. So C is 25 over 13. I like it. I picked a yummy one. Now, if you're worried, look, CS minus BS. So C minus B has to equal 2, right? Let's see if this is true. Oh boy, this will suck if it's not. C minus B, 25/13 plus 1/13, right? C minus B, 25 plus 1 is 26/13, which is 2. Yay. So there's a relation I didn't use, but that's like my check relation. Why did I get a relationship I didn't use? Because I had a shortcut way to get one of them. So you can just kind of check to make sure that relation holds if you want to. So what did we figure out here? We figured out that this equals what? A is 1/13, so 1/13, 1 over S minus 1. B is negative 1/13. So we got minus 1/13. Oh, crap. I'm running into stuff. You guys got those notes, right? Everybody got that jotted down? Thank you. Everybody saw there's a quiz one? Yeah. All right. Where am I at? Okay, so B is negative 1/13. That's negative 1/13. S over this. I'm just going to go ahead and tear those apart on the way through here. And then C was 25/13, so 25/13 times 1 over S squared plus 25. Now, can you see ahead what's going to have to happen? Which one of these needs a little bit of balancing? The last dude. And of course, what's supposed to be on top?
5.
5. Cool. So I can just pull a factor of 5 from him. All right, now everybody's balanced. Now I can do the inverse Laplace. All right, let me stop. You guys, most problems are going to be exactly like this. How can they be more disgusting? Well, they can have gross partial fractions. Okay, well, that's just as methodical. Be careful, right? They can have what we're about to talk about next, which is translations on the s-axis, which involves completing the square in the bottom sometimes. Shit. Well, let's see. We're not there yet. We're still at a relatively nice place. Inverse Laplace, both sides. So I get y of t equals, what do I get here? 1/13 e to the t, e to the 1t. Yeah. Minus 1/13, who is this?
Cosine.
Cosine. Cosine of
5t.
5t. That's an S, remember? Oh, that's awesome. That's an S, and that's a 5. I'd be so happy that I don't handwrite my tests. So this is minus 1/13 cosine of 5t plus 5/13 sine of 5t. So you can see these would be the particular solution from this, right? And this would be the YC with the constant figured out because of the initial value. Okay. So I think I mentioned what this thing does, but we didn't really prove it. Can you guys set up what this is? The interval for this? The actual, go back to the basics. the interval related to the Laplace transform. Set that up.
Back A to the T, or E to the AT.
E to the AT, yeah. I kind of already told you what's going to happen. Well, let's see if you can see it happen. It's a little messy. That made you feel good for me to say that, but at least this is not graded. That's too bad. So this is now a function I'm putting in, right? So what's the kernel of the Laplacian transform?
E to the negative.
Yeah, so that's there, waiting, and the thing that I'm transforming is this. Now, of course, here, what can you do? Yeah. And let me do this, well, is that going to be... Yeah. Let me do this. The reason I'm doing that is just because it really shows you what's normally here is e to the negative st. Now it's been shifted over by constant a. So if I just keep going, if I just follow my steps, this will be, I'd have to do by parts, right? So if I do this by parts, u would be what? Believe it or not, so in general, I'm going to let u equal this, because tell me this, what's the integral f, you can get it, just get it away. It's the integral ft, big SF, right? So if I let u equal to this, then du is what? Yeah, so it's going to be negative s minus a e to the negative s minus a t. And then dv is going to be f of t dt. And then v is going to be the antiderivative of f. Isn't that crazy? So what am I assuming then? That little f has an antiderivative, right? So then what do we get here? We get, oh, this is not as quick as I wanted to do. Let's do that. So you get uv, so you get e to the negative s minus a t ft, evaluated from 0 to infinity, minus the interval of v du. Oh, did I do this in the right order? That's going to be awesome if I did do it in the right order. Yeah, I think I did it in the opposite order. It's too bad for me. V du, that would be s minus a e to the negative s minus a t big S f of t. That sucks. I think I did it in the reverse order. Alright. Alright. Just bear with me. What's going to end up happening? I knew I should have done that before. For some reason I thought we'd already done it, and I was like, you just get this. Eventually, if you do this by parts correctly. Oh. All it ends up doing is translating on the s-axis. I feel a little bit perturbed that I couldn't do that, but oh well, too bad. So that's, I kind of pointed it out in a few different ways. I reminded you earlier about this, that when I multiply by this, it ends up just shifting the result. So normally this would, if it was integral e to the negative st f of t dt, I would get fs, right? So now if I do integral e to the negative s minus a t f of t dt, I should get f of s minus a. Now me, I didn't want to stop there, but oh shit. Sorry, I did this out of order. Too bad for me. So what that means is if I see something like remind me, what is the Laplacian of t, for example? Yeah, 1 over s squared. So the Laplacian of e to the negative 5t, t, it's going to be 1 over s plus 5 squared. So it comes into play with inverse Laplace also, obviously. All right, so if I don't know if you guys remember, if I had like ys equals, what you got, Jeff? It's a good question. S over s squared plus 8s minus 3. This is what I said earlier. It involves, can you factor the bottom? Nicely at all? No. You get all kinds of crap. You hope to God there's a better way to go about it. And yes, there is. I can just complete the square here. So the s squared plus 8s plus 16 minus 3 minus 16. And then that's factorable. Get in there. Yeah. Work. Now this is now get out of there. What do I do with this? I made one that's worse than I wanted to. I told you I wouldn't worry about hyperbolic. Is that related to hyperbolic? So it's oh well, it's too bad for Jeff. Too bad for you guys. But you get the idea of what you have to do. This would be a shifted answer, right? It's going to have an e to the negative 4t times whatever it normally would have been. So what I normally tell people to do is if you're trying to inverse Laplace this, you put e to the negative 4t, and then you rewrite this for yourself. You took care of that shit. Now write next to that what that would be. You already took care of the shift. Now write it without the shift and just do it like normal. So let me give you this, and then I'll let you guys out. Here's just a little summary. Something you should be able to do on your own, but I just want to give you this. This is what all these Laplace transforms look like translated on the x-axis. Yeah, on this one I didn't even put the cinch and coach. All right, so Monday, yes?
So it's totally root 19?
Yes, because K would be root 19. I like it. And that's S, so it's going to be cosh, yeah. I like it. So that would be right there. Because you take care of the shift, and then you do it as if the shift wasn't there, and put that next to it. I like it. So Monday, quiz, Laplacian stuff. I can't remember the rest of it. That's what was up there. Our test is on the 16th, so it's still a little ways out, but closer than you wanted it to be. And then the finals come in